All right, cool. So let me just get the document camera up. So task number 3 for week 6 remote work was a CPR quiz. The CPR quiz is just recapping that Lewis structure and shape material that we've talked about so far. This isn't a full NCEA question. Lewis structure and shape tends to be a segment of a question, and they might shift it and add it to other things. Usually you see it with Lewis structure, shape, and polarity, but things might move around a little bit. But anyway, I still wanted to show you this question. I'm not obviously going to answer it in full because you have the marking schedule provided for you. The main thing is for me to show you how to decode it. I realize there's already a typo on here. That's the 2021 exam that we're doing. All right, cool. And this is question 3A and B. This first one here is just about Lewis structures, drawing them, and then naming the shape. I won't go through the process of actually drawing and naming it because I don't think there's a huge benefit for me to do that because it is on the marking schedule. So hopefully you got those ones right. If not, send me a message and I'm happy to make a video explaining how to do any of those molecules. Basically though, this one did go up to a merit level, and it's just a matter of how many shapes and Lewis structures you got correct. I think they were quite generous with this marking schedule. I've said this before, and I think it's because they're mindful of all the lockdowns that happened in 2021. So you only need to get 2 Lewis structures correct with their shapes. So meaning you could have gotten one of them wrong and you got a merit. Usually I see it is all of them need to be right for the merit. In this case, for the achieved, you either got 2 Lewis structures correct or you got 2 of those shapes correct. Worst case scenario, if you're not sure what to do, please just take a guess on the shapes. Even if you don't know what you're doing, just write down a shape. You have a chance of getting it right because this is kind of more multi-choice kind of question. So do kind of keep that in mind. All right. Next bit is then your bigger explanation question. In this case, they have given you the Lewis structure diagram, and they've given you the bond angle, and they want you to compare and contrast these two, and they want you to explain the difference in the shape and the bond angles for the nitrogens that are colored in red. I have a black and white image, so I'm just going to circle which nitrogens they were talking about, which were those 2. So in both cases, they have different shapes, and they also have different bond angles. So it gives you a lot to compare and contrast. The thing that's similar, obviously, is that they both have nitrogen that you're dealing with. And not only nitrogen, but 2 nitrogens. The reason why I wanted to point out this question to you guys is to show how kind of funky the questions can get. And I'll show you some of the no brain too small collated questions as well. It's really important that you read the question carefully. So in this case, they want you to talk about the nitrogens that are colored red only. So you're using that one as your central atom. Because remember, whenever we're talking about Lewis structure, whenever we're talking about shape, we're doing it in reference to the central atom. In this case, there's no technical central atom, so they've told you which one to work with. In this case, I have 1, 2 regions of electron density, so that one's a linear shape. And this one, I have 1, 2, 3, 4 regions of electron density, but 1 lone pair, so that one is going to be your triagonal pyramid shape. So I'll just quickly classify those 2 for you. Again, I won't go through and do a full justification answer because I don't think it's a great use of everyone's time. I'll just kind of walk through the marking schedule. The main thing that you need to think about when it comes to these questions is I want both the layers there. So you should have a layer explaining the angles and a layer explaining the shape. You need to hit both of those points, and you should be using comparison words as well. Make sure you're very clear how many electron density regions they are, how many bonded regions they are. You can see here that they're also using comparison words like while, and that shows that they're doing that compare and contrast. So do kind of keep that in mind. Again, you see that while, and that's going to show that real integration of information. And you can see that they've both done the bond angle and the shape as part of the justification. For the achieved, only 1 point, but there were multiple ways to get it. The first thing was just identifying the correct number of bonded and unbonded for one molecule. So again, this is another good example of where you could just take a guess. And in fact, they've given you the Lewis structure shape, so you could actually just look and count. So use that to your advantage. The second one was recognizing the electron density regions arranged to maximize distance, minimize repulsion. That is just a generic kind of regurgitation of information. So that's a really good thing to write down. If, again, you're struggling, it can get you an achieve point if you just state something about Vesper theory. For the merit then was just getting the justification right for one molecule. And in that case, you needed both the bond angle and the shape to get that. I have seen other marking schedules where they have you got one molecule fully correct or you got the shape correct for both molecules. It really depends on the marking schedule. So do kind of keep that in mind. It is worth writing both of them up because if you make a mistake with one of them, you can get the other one right. So do kind of keep that in mind. And then the excellence was that full justification of both the molecules, bond angles and shapes with all relevant factors. So all relevant factors will be Vesper theory, things like that. And do stick in the word while or however. Really great things. So that's all really for that CPR quiz. You'll notice that there's obviously a part C, and that's the enthalpy calculations, which we'll do as our final section. And you can see here that they have another question on polarity, which we'll do towards the end of this section. So do kind of keep in mind that the shape question isn't usually enough to be a question on its own. So you'll probably see it within other questions. The other thing I want to do is go to No Brain Too Small and just show you some different versions of how they ask that question because they can do some really funny things and I don't want you to be thrown off if they do something funny. So if we go to the collated questions on Lewis structures and shapes, you can see kind of the variety of how they ask that question. There's one in particular that I had in mind I wanted to show you. So you see what I'm saying? They love to do that comparison where they have the same bond angle but different shapes. I'm trying to find one where they give you a big molecule. I might also just be thinking about a mock exam. Aha, this is the one I wanted. Yes, this is evil. This is 2014 though, so it was a while ago. Sometimes they are super nasty and they give you a big molecule and they want you to compare and contrast things inside that molecule. So just be mindful they'll label things as X and Y, and what they want you to do is just kind of treat it as a section and justify it that way. So don't be thrown off by it. Just treat it exactly the same. Just treat it as as two separate molecules. So for this one, the central atom is the boron, and there's 1, 2, 3 regions. They say that the bond angle of X is what you're thinking about, and the shape at this section of the molecule would be triagonal planar. In this section, with the oxygen as your central atom, it has 1, 2, 3, 4 regions of electron density, so the Y is going to be 109.5. And the shape in this section of the molecule is bent. So they like to do that sometimes. Watch out for that. But you would explain it exactly the same way as if you had two separate molecules. You process it in the same way as two separate molecules. The only thing that's weird is that it's one giant molecule and you're basically isolating specific sections to think about what the shape is in that section. But you'll use the same justification. And then I just wanted to see if there's any other ones that were kind of funny to point out to you. I think they're mostly okay. Every so often they throw a curveball. Yeah, I think all those are fine. Sometimes they're also really mean and they don't actually give you a molecule. They just give you like A, B, C, and D. And they don't actually tell you the elements, but they'll give you the information of the bond and the electrons. At least to kind of get you started. I think I saw that on here we go. Element X has 4 valence electrons. Another element, Y, has 6 valence electrons. They combine with oxygen, and they've given you the formula. It's okay if they've given you an element that's not named. Just treat it as any group 14 atom. So treat this as it was carbon, would be my suggestion. And you just work through it the same way. But that's 2008. So that was from quite a while ago. But it's just good to kind of look through. Even if you don't have time to answer all the questions, just have a read through them just so you can see how they ask the same question in different ways from year to year. And then this should have answers at the end. Yeah, they do. Okay, cool. So that's that for Lewis structures and shape. Next week, we'll start taking those shapes and linking it into determining polarity. And then with that polarity, we'll link that into solubility.